First, I'd like to explain why I'm posting this video. A friend of mine gave me this Grundig 260U stereo receiver, and when I turned it on, I got distortion in both channels. My search for a solid state Grundig schematic fell short from this era, so I set out to develop my own. Here's kind of an example of what I started out with. The traces on the foil side of the board, which I'm not going to flip this to show it, are almost as green as the circuit board. I had a very difficult time distinguishing the two. I do have a picture of it up here. So here's a picture of the traces, and it's just very difficult to distinguish between the two. Not only that, the board is long, the board is wide, the power transformer is way over here at this end, which is probably good for noise. The opposite end of the amplifier section, which is over on the side. And tracking the traces was very awkward. The long strips of trace extends the entire length of the unit into here, the amplifier section. And the long strips of trace, each bank, which I named T101 on the outside, T201. So this is 101, 102, 201, 202, considering I couldn't read anything on here to tell me what they were, and I needed a reference. So I made my own, and I wrote it on the side here. You can't see that. The inside channel, let's see. Now, this transformer has a power supply that runs over to this bank all by itself, another winding that runs over to this side. Each of the sides run to their own separate fuse, and I'm not sure if I can point out the fuse, but right here is the fuse. I'll zoom in on that a little bit. And this side has its own fuse, its own rectifier, the two transistors. It has its own filter capacitor. And then over here, there's a fuse back here, which I can't even see. Another rectifier, the filter, which I left the old filter in because it's good. And then it has its own speaker capacitor here and here. And then it has a coil that feeds into it and a coil that feeds into this one. And then there's another coil that feeds into the wires that go over to the speaker. So it has two separate power supplies just for the output transistors. I called them source 3 and 4. I had to call them something, so I called them source 3 and 4. Another trace leads from the power supply transformer in another direction over here to a fuse here. And the fuse here then feeds a bridge rectifier, and the bridge rectifier then extends all the way over to this section here. And it comes into resistor 14, which is here, and resistor 58, which is here. I know it looks like a hack. I'll explain that in a minute. Now resistor 14 goes through this coil, then through this wire up to a Zener diode. And of course I'm just not being able to see that in the frame. There's a Zener diode right there. Isn't that something? No matter what I do, I can't see that on the drawing, on the video I mean, because the antenna has blocked it. There it is, the Zener diode. Okay, now that doesn't just go there. It also goes back the other way to this capacitor here, which is the filter capacitor, and that would be capacitor 143, I believe, 1000 microfarad, 35 volts. There's another stop along the way under the board that goes to the FM radio switch, and then off to who knows where. The second resistor over here which I believe is resistor 58, I call source 2. Now that comes over to the two output transistors over here. Not output, but the driver output transistors that supply power to the output transistors. It goes to the collectors of those. And on the drawing, if I can find that, well, T9, I don't know if we can see T9 here. At T9, the collector is there. And then also for T13 on the other print. So that that's the driver transistor. So I call that source 2. So anytime I see it on my drawing, it's source 2. And what are we looking at now? Must have moved the camera. So we're looking at the stop along the way, then we have the Zener, and then we looked at over here, we have another resistor back over here next to the fuse that supplies power to, now this lead here is going to the antenna, which is of course blocking my vision of this. There, that resistor, and that goes off, and I've disconnected it at times, and the radio still works. It shows on the print what I think is a picture of a light bulb, but I'm not sure where that goes. I just disconnected it so that I could remove the loads. So building the schematic wasn't easy, but it was a lot of fun. One of the main objectives was to not do any harm to the unit. When it comes down to doing harm to the unit so that somebody can't repair it later if I mess it up, that's not what I wanted. It could be, you could throw it in the trash if you wanted to. I didn't expect it would work that great even when it was fixed. That meant on the back side of the board, or anywhere, I wasn't very quick about taking a soldering iron and starting disconnecting these traces. These traces are old. The more times you hit them with a soldering iron, the better chance you're going to have of messing them up. I didn't want to do that. So, one of my main objectives, no harm while exploring the unit. No soldering iron, anything until I had a clear understanding of the circuit. The traces are too sensitive to be casually heated unnecessarily. My main objective was to have fun, and I had a grand time working on this thing. Still enjoy it. Now, flipping the unit over and back again, it's not exactly light. It's not exactly light. The chances of breaking things are a lot, so it was very difficult. So that's one of the problems with making your own schematic. The components and their components, flipping it over and back to identify components and their connections was a daunting task. The unit's not like most of the components are listed on the top side of the board. So if I can zoom in here on the top side of the board, I can see that the units, the components are listed. Now you have to flip them to the side here and the side there to see what they are, but many of the components are listed. Not so on the other side of the board. Not so at all. And so when I went to the other side of the board, I would get so disoriented that it took several trips back and forth. It got to a point where I was putting leads on and then tracing them out with an analog meter, an analog type of a voltmeter that I could zero, so that when I zeroed it in, I could tell zero from almost zero or not zero, so I was on the correct component. Just casually, like I say, unsoldering leads was out of the question. You could say, well, I see where your capacitors are just J-hooked in. And I know that there's several people out there on YouTube who say, you don't J-hook, you go down and you solder correctly in. Good for you. If somebody later on wants to take this thing and do it perfectly, at least there's no harm done to the traces. Have at it. I think J-hooking it works just fine. The best of intentions turns out to be the biggest error you ever made when you're trying to get in and do things. And I can tell you that right now, because without trying, the one damage I've already did was the switch over here. And this lead, the FM radio connectors, sure do get in the way of everything. This lead, this bat on the power switch is broke. So that when you turn the power off, all of this moves. And if I can get to the right switch, off, you can see everything moves. And I'm going to FM, that's why it's making noise. It shouldn't be going on and off. Well, it is. The circuit's in the radio. The power is not going off on the unit. And that's the FM radio. But we'll go over here to auxiliary. We don't want the radio on. So I did do damage messing with that capacitor over there without even knowing it. And of course I think that happens to be a switch around on the world I'll ever find one. Now, while surfing YouTube, I happened to find another video from Shango 066 on Grundig, solid state. I think I saw it before, but I watched it and enjoyed it, but I didn't pay much attention that it happened, whether it was anything close to the unit I had. Well, come to find out, when I looked at the YouTube video, it was the same as the unit I was working on. Pretty close. And his prints were indeed, he said they were fuzzy and he couldn't see them and understand them. So let's zoom back here a little bit. And I'll say I took screenshots of his prints offline. And he had things I didn't have. And even fuzzy, I was able to get somewhat of a drawing that I could use to develop and enhance the schematic that I had. So my schematic went from something like this, which I understood, something like this, that I understood, to something like this for the power supply, and something like this for each of the channels. Now don't take any of the voltages that are written there, because they were written using the original voltage when I first started working on the unit, when it had distortion, and they were taken using the auxiliary power supply And so there's different notations for each. And so you don't want to take them as if they were the ones. But anyhow, the print helped me a lot. I pieced all those pieces together, and that's one of the reasons I posted this. Is I'm going to try to throw in the schematics so that if somebody's working on the unit and said I can't find any data on it, that it would help them. That's all. And not only that, comments will be a great deal of help too. Now, one of the advantages of working with a stereo set is that you have two amplifiers. You have the left channel and the right channel. And you can take the left channel and compare voltages and readings with the left channel. Well, in this case, both channels had the same distortion problem. So that led me to believe, every time I would think there was something in the output section that would cause the problem, it would cause me to think, no, that's not the case. So I was drawn back and forth. I mean, what would make these transistors, or these transistors, or these transistors, or these transistors fail the same? So I sit there and I get torn back and forth. Obviously the power supply would be the problem, and anytime you're dealing with power supply, capacitors, which in this case were not the problem. So the reason I told you about this ugly looking lead over here is that every time I did finally get to a point where I was going to pull a component loose from the foil side of the board, I didn't want to keep reinstalling it and then connecting it again. So I would always take a resistor and put the lead up through where I could get to it, and then solder it on the board, so when I was making the connection on and off, it was up here. Didn't have to flip the board over to do it. I didn't have to keep reconnecting the joint, the trace. And the same thing I did with the driver transistors too, the final drivers, because they're in a place I just can't get to. Now I can get to the leads, and when I get to the leads, so putting the probe in and out of the circuits in here, there's an awful lot of metal there. And I can easily short something out. And the thing about these solid state circuits, you short something out, you could burn everything up. This one's pretty forgiving, but I've seen cases where many are not. I remember working on a Magnavox one time, and I made a connection, blew out both output transistors immediately. Anyway, so in this case, I decided I needed to disconnect the collector of the transistors. So I wanted to see, are we loading the circuit down? Or is something here loading the circuit down? Because I couldn't get more than 27.7 volts, as I mentioned earlier. So when I took the collector lead loose from T13, it came loose just fine. When I took the collector lead loose from T9, the whole transistor fell out. So I guess I've been wiggling it around enough. While it was out, I tested it. It was perfectly fine. I used one of those transistor testers that I had ordered online, using the meter method. And of course, by that time I had a print, so I knew which one was the base collector and emitter. But the transistor tester made it clear which one was base collector and emitter. And I thought, was it good or bad? Again, like with voltages, I didn't know. I take a look at my notes here, and be careful because the unit is on, and that's T9 right there. FNRST, that's the type of unit that I have. Transistor looks fine to me. So I again took a resistor for the transistor that fell out and put 3 leads up and pinned them to the board and then tacked the transistor in. The reason being, again, how many times did I want to take it loose and put it back, or maybe try a different transistor, which I never did. And I never did pull T13 all the way out because the collector lead came out just fine. I did put a pin up through there on that one so that I wouldn't have to mess with the circuit board. Flipping the unit, messing with the circuit board, not a good idea. Regardless, I might have mentioned it already, no matter what I did, disconnecting all the loads, disconnecting everything from here and here and here. I even pulled these transistors out in the 101 section and checked and had the same problems. Could not get more than 27.7 volts. And I said, well, I can't obviously find any problem. So what I did was I replaced the bridge rectifier, which is down here, and I went from that bridge rectifier, which is quite hefty, and the original bridge rectifier, which is this unit right here. As you can see, there's quite a bit of difference in size. So we may have just solved the problem by overdriving everything. I don't know. All I know is that I replaced the bridge rectifier with a hefty one. The voltages all came up. It works. It works much better than I ever thought it would work. I can put it on the scope. I can put signals into it and see that they're okay. I haven't measured the wattage or output. I don't plan on playing it like that. I just know that it sounds really good. Especially for an amplifier this age, I didn't think that it would be anywhere close to that good. And especially that the speakers are really small. They're like 4x6 speakers, 2 of them. So they're really small. I ended up getting 32.3 volts. I think I've already mentioned that. I ended up getting 15.4 at the center. I ended up with 0.3. And at the collectors now of T9 and 13, it's all the way up to 10.7 volts. So it's actually high. Could be that the transistors are drawing it down still. Something I can't find elsewhere is drawing it down. But it's been 3 weeks now since I changed that bridge rectifier, and I play it every day. I plug my phone into it through the DIN jacks, or I play a record through it, and it sounds pretty darn good. Also can play tapes. So that's pretty much it. There's a whole lot of data that I took, a whole lot of things that I took. I just wanted people to be familiar with it.